right, sixth grade crew. So we are talking about transmission and absorption today. We've talked about reflection. We've talked a lot about light energy. So now we're going to kind of finish off our light energy lessons with kind of making sure we understand the other ways that light can interact with objects. We know that light has different properties, and we know that it's the reason that we can see everything that happens around us in the world. We know that light is why we have reflections, because light can bounce off of objects. So there are also different things with absorption and transmission. So if you've ever worn a really a dark shirt, like black or navy, on a really hot summer's day, you know that shirt can get so hot. Or the black top on a playground or on the road, it gets really, really hot on a summer day. That's because that light is getting absorbed. That light energy is getting absorbed into those objects. If you've seen light pass through an object, so you're looking in the window at your friend and your friend's looking through the window at you and you guys can clearly see each other, that light is getting transmitted into those spaces, and so you're able to see each other. So we're really going to just focus on those two things, transmission and absorption. Definitions we already know. So just as a reminder, absorption is when light is taken up by the material, reflection is when light bounces off of the material, and transmission is when light passes through the material. My computer has been super slow today, so sorry if it takes me a second to load. Okay. So we know that light is a form of electromagnetic radiation. It's the part that we can see on the electromagnetic spectrum. So properties of light waves can allow them to pass straight through glass windows. So the people outside of the window can see you and you can see them. So when light travels through a medium such as air or glass, we say that those mediums transmit light. And that process becomes known as transmission. Light can be transmitted through some materials, but not all. And we're going to explore that a little bit more. So, for example, when you're looking into a glass window, you can see the things through it pretty clearly, but sometimes you can also see your reflection a little bit. Maybe not super clear, but you can kind of see it a little bit. And that's because when you're thinking about glass windows, some of the light is transmitted through, but then some of it is reflected back through that glass. And so that's why sometimes you looking in a pool, you can see an object that's at the bottom of the pool, but then you can also see your reflection at the same time. So basically, the amount of light that gets transmitted or reflected really depends on the property of what it's reflecting or transmitting through. It also depends on the frequency and color of light. So basically, the process of transmission and reflection will pretty much always affect the path of a light wave. We know that light usually travels in a straight line. We know that when it's reflected, it bounces off something in the exact same angle. But when light passes through something, that light can get bent or changed, and it's called refraction. It can also get scattered in a ton of different directions. When light strikes it and it passes through it without scattering it, the material is called transparent. So clear glass, pure water, air, those are very transparent, and we can see clear images because of that. Some materials can transmit some light, but the images aren't clear, and those things are considered translucent materials. So if you've ever held up tissue paper, colored tissue paper, up to the light, you can see the light glowing through it, but you can't necessarily see clearly what's happening on the other side of that paper, so it's translucent. And then if you cannot see a clear image at all, because no light is getting transmitted through, then the material is called opaque. Load. There we go. All right, so now we're going to kind of switch gear and focus on absorption. So Materials can absorb light waves that strike it. And when a material absorbs light, it's often converted into heat energy, which is why we tend to feel that certain things are warmer than other things. So if a light has a particular wavelength, it can cause an electron and in an atom to actually increase in energy and jump to a higher energy level. So when that happens, the atom absorbs that light wave. So different atoms absorb different wavelengths of light. If the light wave doesn't have the wavelength of a particular atom that the particular atom can absorb, then it's either going to reflect from the material or be transmitted straight through it. Different materials absorb different wavelengths. And then again, when it does absorb, it can cause an increase in temperature. The color of an object depends on light absorption. So most of the light around us is white light, which means that it contains all the colors of the rainbow. So the different colors of white light all have different wavelengths. Since materials absorb particular wavelengths, they reflect others. So like an orange, like the fruit that we eat, it's going to absorb every wavelength of that white light except for orange. The orange won't interact with the atom the right way, and so that orange light is reflected, which is why the orange looks orange. Same with apples and all sorts of things like that. Black objects, they absorb all the wavelengths of white light, every single one, all the colors of the rainbow, they absorb them all, and that's why we see black. White objects do the opposite. They reflect every single wavelength, all of those white light colors, and absorb none of them. So that's why a black object is going to become really hot, because it's absorbing every single wavelength, whereas a white object is going to stay a lot cooler because it's reflecting every single wavelength. So in the real world, most objects are going to do kind of a combination of transmitting, reflecting, and absorbing light. And I think, guys, we are down to just going over our key points. Not too bad, right? So, first key point, if it's going to load, please. There it goes. Okay. So our first key point is all about transmission, right? So we had two big things, transmission, absorption. So transmission, what is it? How does it compare with reflection? So it happens when light passes through a material. This can only happen if the material is transparent or translucent. And transmission is the opposite of reflection. Reflection bounces off. Transmission passes through. What's absorption? So absorption happens when a particular material absorbs light energy. It's usually converted to heat energy, which causes the temperature of the material to increase. Some materials absorb particular frequencies of light and reflect others. That's why we have certain colors. Black materials absorb all the frequencies of visible light. White materials reflect all the frequencies of visible light. And that's how we see those colors. So I think that about sums it up. I hope it helped, guys.